Douglas puts in the request from his home, which server is going to offer him the lowest latency output and do that on a global basis in real time.
So it seems like every day a new mind-blowing AI feature is released. And in that newness, it's easy to overlook that a lot of those AI features are kind of slow. Isn't that right, ChatGPT? ChatGPT. It isn't just voice. There are a whole bunch of new product and features coming constrained by the current infrastructure powering AI tech. That's because AI has a latency problem. And it's okay. 30 years ago, we were excited to load a photo on our website or download an MP3. And then tech built the infrastructure, allowing for near real-time everything. This week on the BetaKit Podcast, we are joined by Rade Kovacevic, founder and CEO of Ottawa-based company PolarGrid. He's going to explain AI's latency problem, why it happens, and the tools that are needed to solve it, along with those new experiences that might come once AI can move in milliseconds around the world. So, what comes next? Let's dig in. The BetaKit Podcast is presented by Fasken Emerging Tech, supporting trailblazing startups, venture capital funds, and acquirers of high-growth tech companies for over 30 years. If you're curious about the health of Canada's tech M&A scene, well, you've found the right podcast, but you've got to check out Exit Insights. It's a first-of-its-kind report from Fasken's emerging technology and venture capital group that analyzes private M&A activity among VC-backed and high-growth tech companies. You'll learn how buyers and sellers are maximizing value, minimizing risk, and navigating one of the most vibrant tech ecosystems out there. Download your free copy of the report at fasken.com/en/tech-deal-study and let them know that BetaKit sent you. All right, Rade, thank you for joining me here in Toronto. You've come all the way to do just a podcast conversation, I'm assuming.
Yeah, just a podcast, no meetings or anything else.
No, nothing else going on.
All the far away from Ottawa.
Well, yes, because I sounded the pod alarm. Because when we were having a conversation previously, you told me that Gen AI was having its GeoCities moment, and I immediately was like, that's a podcast. You need to come to Toronto. We need to talk about this. As someone who remembers GeoCities and then likes tracking the current state of tech development through previous eras, this hit me right in the chest. Explain to our audience. Well, maybe we have to explain what GeoCities is at some point, but what you meant when you said that.
Yeah. So it's the moment my kids would call me a boomer, despite my age. But
we're totally uncooked. 3 other words I don't even really know.
But so I think the way I like to think about it is market cycles rhyme with each other. And so when we look at large market shifts in tech, what I often want to do is find the analog from something that's happened before. And that way I get to learn from other people's mistakes.
It's awesome.
And so when I was a kid and about 10, 11 years old, I started building websites, and it was super exciting because adults had no clue what they were.
Yes.
And there were these things and companies like GeoCities. And so basically GeoCities would give you a template website, super rudimentary compared to what we have today. It'd give you some HTML code and you could build off of it. And so what I sort of looked back on as we were looking at where Gen AI is in the cycle today and compared it to sort of that mid-90s .com boom, what we found is that there's consistency between what we would accept when there are market shifts, the features and capabilities we get super pumped about, and where the user expectations end up. So if I take you back to my childhood bedroom when I'm 11 years old, we're building on GeoCities. And we're super pumped because there's now pictures on the internet.
Yeah, you kind of undersold it. You were like, you can put, there's a template and you can put things on the internet. That was mind-blowing. Not only just pictures, we had GIF technology, even in the 90s.
Yeah.
That under construction GIF of the GeoCities page you were going to build eventually.
Correct.
That was going to be awesome.
Sometimes that GIF would even move if you're lucky in 2 or 3 directions, right? And so you would build out these websites and you'd have these images and they'd take 30 seconds to render.
Yeah.
And no one gave a shit because it was fantastic. It was better than sending something through the mail over a week.
Yes, because rendering itself was novel.
completely novel at the time. And so that was sort of the foray into it. And you think about a year or two later, so you get to around 97, 98, and Adobe Flash is blowing up. And for those that remember Adobe Flash, it gave you animated images to intro to your website. So you can make, pictures move around. But again, you had over 30 seconds of loading time. And so we'd make the word loading move all over the screen. Everyone thought it was super neat and innovative and differentiated. I think the important analog to think about with that is at both instances, 30 seconds was not a problem. It was a high five moment and a win.
Absolutely.
The difference today is tens of milliseconds would be a loss. And so what's happened is as we've gone comfortable and used to websites loading, user expectations have increased. It's become an important piece from a competitive set as you're looking to rank on Google, as you're looking to not churn users as they hit your website. And the expectation is much more clear today.
Absolutely.
That's how Gen AI feels to me right now, where it's super cool, all these features and capabilities. We learn new things we can do every day, and it all takes a super long time to load. And I can't believe that that's how we're going to experience AI 5 years from now.
Okay. I totally, because there's a number of people that are either watching or listening to this that maybe bounced off in the first 5 or 10 seconds if they were on a poor connection, or like the YouTube video was
totally,
or my intro to this video wasn't as compelling as it should have been. We are definitely in the not only like the millisecond experience era, but like that speed for judging the value of the content. I totally get what you're talking about, and I fondly remember waiting for the JPEG or the GIF to load. I'm having trouble reconciling what you're describing the current Gen AI experience as slow, given how maybe, again, it's just the novelty of it, that this stuff is so new that you can be in conversation with, I guess, a web page, and it's not just putting an image, it's generating an image, it's creating documents for you, it's generating all sorts of things. That is still so novel. I'm struggling with the speed of it. But you have the engineering background. You're not just doing this from like the 10-year-old in the bedroom anymore.
I was pretty good at engineering when I was young, but sure.
Yeah. Okay. I was just like, this is cool. I'm going to go play computer games now. Love it. I'll work on that web page eventually. Like one day my GeoCities page will be super awesome. Talk me through when we look at the current state of like frontier tech, totally novel experiences from like, let's say 2023 on to today, just a new era of how we do things on the internet, the components of that which are ripe for optimization. Like what's the Adobe loading screen equivalent that we can optimize for? And why the fuck does that matter? Like, what is it going to change?
Yeah. So I think at a high level, let's take a step back and think about the pieces of the chain that impact end-to-end latency, which is really the time it takes something to load for me as a user to get the response. So the first difference from the traditional internet is the traditional internet was static data. So you have static files, whether it's websites, whether it's streaming, but these are existing pieces of data that need to load and be served up to a user.
Yeah. Like an HTML page calling specific graphics that then load in order. Like we even have to take a step back. Like the idea of static things being loaded is kind of weird in an environment where every website is like post Ajax dynamically updating and altering. It's like if you wanted that page to change, other than maybe the Giphy moving, you had to refresh that shit. You had to load it again, right?
Correct. And so the way to think about it is, if you go back to like 1997, a company called Akamai gets founded. Yeah. And what Akamai basically says is, this is all going too slow. We need to find a faster way to get things to load. And what their insight was we had centralized cloud compute resources. So think of, the AWSs of the world nowadays.
I'll point my finger to the error of the episode that we did with Ian Ray about the recent AWS outage to know that that is still a component of our current tech stack.
And still a problem.
Yeah, still a problem. But please continue.
And so you have this situation where they say, if we put the infrastructure closer to the end user, when the end user, makes a request, it hits the infrastructure. And because it's not traveling as far, it can load faster. And in addition to that, we can use caching techniques to remember the data so it doesn't have to be pulled from the centralized cloud so that it can load faster. And so that basically evolved between 97 and up to today. And you had originally Akamai, then you had Cloudflare come along as mobile came on, and then you had Fastly thereafter as social and streaming came online. And so that was the underpinning. As we moved into the Gen AI world, what happened is we started to have huge demands for compute, because the difference is it's not now static data, but you need computations to happen based on user input. You have your tokens exchanged, and you have different answers each and every single time.
Just way more dynamic.
Far more dynamic, different physical infrastructure, different model infrastructure. And as a result, we saw all these amazing products be created.
Gotcha.
So you think of your ChatGPT moment, you start seeing people get the value of where generative AI comes in and all the other products that have come since then. And all of a sudden, you see this huge onslaught of demand for AI inference. And so inference is the actual reasoning that happens in real time, as opposed to the batch training that happens to create a model. And so as that demand comes on, it grows exponentially. And we've all heard this to no end over the last several years. And so the response is, where is the GPUs? Where are the compute right now? And it's in centralized cloud servers. And so because there is so much demand constantly growing at exponential rate, outstripping supply, the hyperscalers continue to scale that. And that makes a lot of sense. That's what they do well. They do things at hyperscale, and you build it out to try and keep up with demand. The infrastructure outcome that comes with that, though, is we've now bypassed the content delivery networks. So where in the traditional internet, over half of your data traffic goes through a content delivery network or a CDN, you are now having your inference requests go direct from an end user to a centralized cloud service provider that's hosting the model.
Okay.
The impact of that is you have over 3 to 10 times longer network latency than in a traditional internet environment.
Gotcha. Okay.
Make sense?
I think so. Let's break it down. And then I'm going to try to maybe talk through this, and then you'll give me a cookie if I did it well. Because you, in the previous environment you're talking about, the two things that we could really, really control were similar to like Toronto Stock Exchange or New York Stock Exchange. Like if we move the computers closer together, the distance is shorter, which means things can travel faster in distance speed over time. And then the other component that we had with caching was like, well, if we actually save some of this stuff locally, that doesn't always need to travel, like the style sheets, or maybe you've already been to this page CSS, and we're pretty sure there's going to be an image here. The BetaKit logo you've already loaded before. Let's keep that in your browser cache on device, so it doesn't have to travel at all, and we can kind of shorten the situation. But this is still like a almost linear TV, one-way streaming of requesting information and having it be directed to the user. You're now talking about a dynamic where, because this isn't static media, these aren't just fixed assets that we're trying to zip across the internet, there's a dynamic conversation and there's a back and forth. But the hyperscalers are still building infrastructure that is centralized in a way that instead of shortening the distance, we're making it super, super far.
Yeah, and that's totally correct.
Is that half a cookie?
I'll give you 3/4 of a cookie. He did well summarizing it. Yeah. And if you take a step back, like to contextualize ourselves to where we were in 2023, if the computation, so the model's providing an answer, was taking 10, 15 seconds, why would you focus on the last mile of network latency, right? Yes. That piece always comes in after the features and capabilities exist.
Gotcha.
And so like, again, if you go back to the mid-90s, like think of images. And initially we had these large GIF files, and then we learned about how to compress them. You had to get that compression piece done for the CDN solution to network latency to matter. The same's happening with Gen AI. We needed to improve the underlying chipsets and the model optimization to get the end-to-end latency close enough that then you're driving that last mile through addressing network latency.
We also needed like broadband. We needed fat enough pipes that any sort of optimization would matter. And it's interesting. Part of the reason I wanted to talk to you was not only because it's so interesting that you're, again, tying these errors and making this comparison, but when I hear people talking about Gen AI and compute, the conversations that I'm a part of at this level, and maybe this is a little bit more consumer oriented, are so much more focused on cost and power than latency. Are you jumping ahead to the next stage of optimization, or are we seeing the industry start to transition to, okay, everyone's buying NVIDIA chips. We've got that. Now, how can we That's stage one. How can we optimize on top of that?
Yeah. And I think the way to think about it is stage one is we had to get GPUs capable of doing compute, right? So we had those breakthroughs in the 2010s and moving forward and how we could take advantage of GPU infrastructure and now LPUs and TPUs and other options. I think then within that leg of the stool continues to be optimized and improved. And we see that with the new Blackwell chips now out on the market as an example. The second piece then is the actual model design. So how do we design models in a way that they operate effectively and efficiently? And that's both at the model design level and that's also at the optimization level. And we see both of those moving forward. The third leg then is the networking piece that makes the actual data traveling over the network
classic
go
infrastructure. This is the series of tubes situation.
Exactly. And so when you think of it from that perspective, you then start saying like, where is the problem today, to your point? Where is this coming up? Who is going to care about these pieces? And if you look at, again, like the analogs from the 90s and you look at the rise of mobile, the answer is folks that are focused on true real-time use cases will be the first ones to hit this bottleneck because they're the ones where the demand from the user, so the user prompt and the response time matters the most and becomes mission critical.
Okay.
And those are locations where you see it. And from that, what you see over time is that user expectations continue to broaden across more use cases.
Okay.
And that reflexivity comes in, right?
So this is like the killer app that drives the need and we have to solve a problem for, like loading the GeoCities page with some static text. And I got to say, really horrible font choices, like real bad. Because that's all we could do. The only changes we could make to the text were changing the font because we had those preset and loaded. But then you start getting these killer applications. You get the Napsters. Yeah. You get the
and Napster's a great example. So think about Napster. Napster comes out, and of course, none of us used it when it was illegal, sort of thing. But
I only use it for research purposes.
Yeah, exactly.
So I think I'm totally fine.
Abided well. So Napster comes out, right? And all of a sudden, back then on our dial-up modems, if you remember those, we're downloading songs and it takes like 12 minutes. And it's like a high five. You got a song in 12 minutes because now you're not going to your local HMV or whatever music store you went to of the day to buy that CD, right? Huge advantage. And at the time, the question would be, why does it need to be faster than 12 minutes? That's way faster than driving to the mall. This is fantastic. You can choose the songs you want. In Napster's case, they're free. High fives all around, right? Yeah. Then things start to get quicker and quicker with download signs. To your point, as the infrastructure gets in place, we start getting high-speed internet, and all of a sudden we're down to a minute. Fantastic. Again, why do I need it in real time? If you loaded Spotify today and it took 20 seconds for you to get a song to start, you'd bump to another program right off the bat.
Assume it was broken.
No chance.
To be honest.
If it took 300 milliseconds, you would jump to another provider.
Well, and then you're talking about the jump from a file transfer system of Napster. So it's, again, we're just sending you the file that you're going to consume locally to now, this is streaming, you are consuming this through the experience. No one would go to a movie theater, no matter how long it took to the movie theater, if the projector itself kept staggering and stopping and waiting, and you actually had to go to get an intermission break to then watch the back end of the movie. We've just made the consumption real time, and we now need real time experiences. You're saying the generative stuff, we're getting close to needing real time experiences. So like, this is the so what question? Yeah. What are the modern real-time things that we need where 10 seconds asking ChatGPT, if I look handsome today, is not enough?
Yeah, so we did a lot of work on this and talked to 100 plus, different companies in the space. And where we found the mission critical pain point is really in voice agents. And it's interesting because you think of, if I talk to a text-based agent or I talk to a voice agent, theoretically, those are both real-time interactions, right?
Yeah.
I think the difference is in text, I don't expect a real-time response. If you and me are sitting there and we're texting back and forth, I know you're doing other things. I'm used to the ... to sort of help me with the human latency that exists there. And I'm okay if you take 20 seconds to respond to me.
That's normal. Asynchronous.
Well, and frankly, it's human-like to be asynchronous, right? Yeah. If I think of a conversation like we're having one right now, I expect you to respond quickly and human-like to me, right? If all of a sudden I talk to you and I can see you're off processing, you're looking another direction, we don't have the flow of the conversation anymore.
Yeah.
right? The same happens with voice agents. There's a natural feeling of it's okay for you to take a second to think if that's a natural place for you to respond to me. But if I can see you've paused because something else is going on, I start losing engagement from that conversation.
Gotcha.
And then in the situation with voice agents, at some point, I ask the question again. And if you're a computer and you're not the human you are today, now you start reprocessing my input request.
Gotcha.
That has more latency. And now we don't have a conversation. We have this sort of interruption loop that happens that causes the conversations to break.
You got like an email thread or something like that. Okay. So no one likes a movie that stutters or a song that doesn't properly stream. In the same way, people who are using this consumer tech don't like a conversation that lags. That's one thing when you can see in the chat window screen, I'm thinking. It's even worse, I'm assuming, when you are trying to have an actual natural language conversation with the AI tool.
Correct.
Either in it understanding you or it responding back to you. And I'm sure everyone, even if you haven't talked to AI, even Alexa or Siri or whatever, just think back to during the pandemic when we were all on Zoom immediately in March and April, and you could tell the people who didn't have good internet at their house because they were like 100%. Always out of sync with the conversation.
And actually, you make the point really well there, because where the industry is from a best practice perspective is they're hitting 600 to 800 milliseconds of latency. So in terms of being fast, it's really fast. The chips have done a great job. The folks creating the models have done a great job, and they've been optimized well. It's under a second, so about 3/4 of a second, sort of the easy way of putting it. The thing is, though, because of companies like Zoom or Google Meets or others, we actually have tons of studies and data that tell us how fast it has to be so that I don't have that shitty COVID experience you just talked about, right?
Exactly. Okay.
And the answer to that is you need to get down to 300 milliseconds, or 1/3 of a second of end-to-end latency response time, right? And so the industry's at a place where the quality of the voices is now quite fantastic. The speed is great, but it's not there where it's human-like.
Yes.
And so it's the right...
Statements are great. The conversation is bad.
The conversation's bad. And it's not that we aren't going back and forth. It's like that bad connection when you're talking to someone on Zoom and you can just tell it just doesn't work, and you get frustrated with the conversation, it doesn't flow. Okay. That's what needs to be solved right now. And I think the takeaway is to say, that is the obvious place where the pain point exists today and is mission critical. The question to the examples we used from the 90s is, where is it going to go after that? Because as users start to see it can be faster, where are the other areas where both the industry as well as the end user of the product have said, this is acceptable? And who are the product companies that are saying, I don't really want to satisfy my users with acceptable. Yeah. I want to have a fantastic user experience. Yeah. And if that is physically possible, I'm going to find out a way to do it.
This is no longer frontier tech. This is now consumer tech, and people have high standards. Okay. Point taken. If we want to get to the movie Her-like quality, we're going to need to do some work. And also, point taken, nobody likes a conversation that drags. No. So we're going to take a little ad break. And then when we come back, you and I are going to brainstorm some solutions to this problem. Or you're just going to tell them to me.
One to two.
Okay. This week's episode of the BetaKit Podcast is brought to you by, drumroll please, the BetaKit newsletter. Every Sunday, BetaKit's flagship newsletter serves up in-depth analysis and insights on Canadian tech and innovation news, piping hot and straight to your inbox. Think of it as a podcast that you read with your eyeballs. With the BetaKit newsletter, you get crisp commentary on the news you need, top Canadian tech headlines of the week, events you actually care about attending, the week's juiciest deals, and exclusive news from BetaKit's partners. Deserves better, and so do you. Stay informed on all things Canadian tech by signing up for the BetaKit newsletter today at betakit.com/newsletter. Okay, so you are teeing up voice as one example where the latency problem really needs to be solved for all of these Gen AI companies and all of these, let's say, broadly AI infrastructure companies, which are some of the biggest tech companies in the world who've been spending billions of dollars on CapEx of this stuff.
Tens of billions.
needs to progress for mass consumer adoption.
Yeah.
Before we get into solving for that and maybe like more detail on the problems of that latency, are there any other killer app, killer UX things that are on the horizon right now that people are looking at other than voice? I just want to cover that off first.
Yeah, so I think there's a number of areas, but there are a few that are a bit more obvious, right? So voice, we've gone over why it makes sense and why it becomes so mission critical to solve. I think the next place I expect we'll see in about 18 months, 24 months is going to be video agents. You can already see companies experimenting with this. So there are companies that focus, for example, on the idea you can book a sales call and then they'll have a sales agent's avatar send you a customized message in your inbox right after. And that's great because it gives you sort of that personalization connection. But imagine if instead of that, I could interact with that avatar as I book the meeting to get the right background to set up for the meeting to come instead of this delay of until it's sent into my inbox.
Yeah. Okay.
And so whether
okay, so I'm going to check raise you because that is like a very business focused use case. The consumer version of that is Disney is taking a stake in OpenAI because it's really cool to make a 30-second video clip of like Mickey Mouse doing something or name your Disney character for your kid. If your kid can start real time playing with Mickey Mouse, well, there's a whole lot of really good sci-fi novels with stuff like that. Ender's Game being one of them, a little dark, but quite enjoyable where like this is just generating like just like every wonderful character from our childhood in real time, like playing with kids, talking to them, but then also like moving around in video, right?
Yeah, 100%. And so it's the same thesis as with voice, just it's with a video representation of it. And you have sort of compounding the problem because now not only do I need the audio to sync, I need that visual representation to sync. And
there's a second latency layer there.
Second latency layer to be addressed that requires even more computational capability sets. And then the obvious place that goes into is the world of gaming. And the example I always give is I have a 12-year-old son. He loves playing online games and he can pick out anything that's AI and not human like there's no tomorrow because it's super obvious because of the quality of the work.
Oh God, and we need to bottle whatever your kid has and sell it because every day I'm looking at new things where I'm further behind on being able to tell and that horrifies me. And this real-time component is even more scary because you don't have the time to go over it again and again and again to check and see if it's generated.
Yeah, and I think there's something about the video game world where the power matching is more obvious. And like there's a great example where 11 Labs worked well to develop Darth Vader, to your Disney example, within Fortnite. And so you had this interactive character that could respond to you with voice.
Yes.
But they didn't come off like a true independent character. You knew you were interacting with the computer.
Yes.
I think that's the gap for the industry to get forward,
the metric
for
here,
gaming to truly adopt it.
And we saw this with Microsoft previously with some of its accounts on social media, TTN, time to Nazi. If you can talk with Darth Vader, how quickly can you get him to say something that would get Darth Vader canceled or immediately pulled from Fortnite? That happened. Maybe we'll add a link in the show notes here. Okay, so again, once it might not be the fidelity of the image or the audio. Now it's the fidelity of the conversation and the interaction that we're evaluating on.
And then I think the other sort of place is, countries looking at dual use technology and so forth is defense tech is the other place latency is going to matter. So we work with a company I think called Dominion Dynamics.
Yep. Been on the podcast.
Been on the podcast. Yeah. So you start thinking about how sensors can work, how you can use models to do different detection pieces that truly aren't in urban centers and truly at the edge. And you start saying, how much do I care about real time? You say a hell of a lot I care about real time. Yeah. So I think there's
different
applications
type of conversation,
there
different
as well.
Type of data. Okay.
Yeah.
Totally. Okay. That's super cool. And now I want to get back to problem solving for this. And you had said something, and we're actually just full disclosure. We're having Rade develop a little bit of an op-ed kind of explainer piece, like a more technical underpinning for BetaKit, because I just think this is a really useful conversation, not only for people in tech experiences, but there's a whole nation of builders who are trying to find where they fit in the stack and they can add value. In that, and we've kind of discussed it, you had noted like, hey, there's like AI didn't follow the CDN playbook that we've been experiencing for the last 30 years. I just want to close the loop. Is that because it can't? Because the way that the technology functions doesn't make CDNs useful? Or that we need to build a new type of CDN? Or that we were so focused on the hyperscaling data centers that a CDN equivalent needs to happen? Like, that's a very broad question, but is there a corollary there in these examples we've been using?
I think the answer is yes, yes, and yes.
Oh,
so
goddamn.
what? Yeah, you did
that,
well.
That is a full
There
cookie
you go.
question right there.
So the way to think about it is we've built it out centralized right now at the hyperscaler locations because that's where the servers were. That's what enabled the fastest response to the onslaught of demand for inference capabilities.
Okay.
I think the second part is, yes, the existing CDN infrastructure is not the right infrastructure because they aren't servers traditionally that were made for inference. You have to get a whole new class of servers built out, and that's why we're seeing large CapEx build outs as inference comes online. And even more, the routing algorithms that were used for CDN. So how did they ensure that the end user gets sent to the right server to get the lowest latency response time? Were based on a different dynamic or different set of variables than you have when you're doing inference.
This is some like, we don't want to get into like dedicated ports type conversation. That's where you're going.
Correct.
Like, if the internet is a series of tubes, there was a bunch of dedicated mini tubes where you'd go to for certain types of data to be transferred. It's like the express toll freeway that only certain types of data can use, which is why whenever you go on a plane or a train and you try to stream or download any content, that train or plane is very, very aggressive in preventing you from getting that information. And it's because it knows what highway it travels on, basically.
Totally. So
I am crushing the analogies today.
You're doing really well. You prepared well. Full points.
No, I don't know. Actually, what it is I took a cold FX earlier today, and I think I'm hyperscaling myself right now. Okay, so that series of dedicated pipes doesn't work in the Gen AI.
Correct. And specifically the orchestration algorithm that tells it how to go through the pipe. So it's not that you're laying new fiber, it's how you tell the request to go from the end user and where to go to.
Gotcha.
And the place it goes to needs to be newly built out.
Okay.
And so the answer is there are certain use cases where sending it to a centralized service is fine. So if you're doing pharmaceutical research and you're doing batch processing overnight, you don't need a real-time answer. That is completely fine. It's going to run for 10 hours. But in situations where you want the real-time output, what we need to build out is new infrastructure at the edge or availability zone level so that we have the right type of hardware in the right places. And then you need a new software orchestration layer that sits on top that's able to say when Douglas puts in a request from his home, which server is going to offer him the lowest latency output and do that on a global basis in real time. Okay.
Because this is also, again, we're talking about it. This isn't just like everybody loads all their JPEGs in the AWS Eastern Seaboard one node cluster. Some of this data that you're talking about for what the dual use defense use cases, proprietary IP, or just fat and heavy audio and image generation stuff might have to be somewhere because like that's where the best people in the world are working on it, or it needs to be localized for like legal reasons. A little bit harder when you're trying to dynamically engage with that data that is Fort Knox, right?
Yeah, and I think to that end, that data needs to be available to where the end user is, not where the producer of the model is. Yeah. And that's the key piece, right? So if we all lived in Northeast Virginia, we could load everything on AWS and everything be super snappy and fast, and we'd high five and pop champagne.
Okay.
But the truth is we don't all live in Northeast Virginia. And so that's what introduces the problem with centralizing the infrastructure. And if you go back to what happened in the start of November when AWS had their outage at that location, we saw the implication. The vast majority of the internet was not set up as a multi-cloud configuration, let alone an edge distributed compute configuration. Okay. It was in one place, and when it went down, it took a lot of the internet with it.
Yes.
And that lack of reliability is a sign of both the issue with centralizing infrastructure deployments, as well as the evidence point of the latency driver that's underlying what's happening in the inference.
Okay, you kind of just said the magic word here in terms of like edge. I think people are getting the distance thing and the centralization. The solutions that you're talking about are predicated on edge devices and edge computing. Can you give our audience just a engageable definition of what that means and where that sits in the stack that you described?
Yeah, so I think there's essentially two ways to think about where the edge can live, and it's really how far to the edge you push it. So
what is the edge?
By
it
the
sounds
nature,
like a fucking Keanu Reeves movie from the 90s. What is the edge?
with speed, but to the point, the edge is far away from the center, right? Like, so think of it that way. How close to the very edge of a cliff can you get? And the furthest to the edge is on device. So that would be to stick it on my iPhone, on my laptop, on my car. That is the true furthest piece of the edge. The next piece over from that is an availability zone. So that's a regional piece that you're able to access the data on. And so the way and that is more equivalent to what the content delivery networks have done.
Yeah.
So the way we frame up in our mind is, what is the use case? Who needs access to the data? How consistently do they use a model? And therefore, where should it live? So it could live in the most basic way, it could live in a centralized facility. It could live in an availability zone. So we're recording this in Toronto. So it could be in a data center in downtown Toronto so that we get sub 5 millisecond latency. Or it could be on your iPhone, so it's near instantaneous, right? The difference with that then turns into what the use case is. So in the future, I'd expect if you're using say, real-time dubbing, so we're speaking two different languages and you want to translate my voice into English so that you can understand it, that should live on your iPhone because that's a simple translation model and it doesn't need to be contextualized. But if I'm a company, for example, that does interviews for corporates as part of recruiting using a voice agent, I can't expect every single person that we're going to interview to go download my app to load my model onto their iPhone. They're going to log into a Zoom call and they're going to interact with my voice agent, in which case the availability zone's the right place for it to live.
You're making an argument for how your company is building this stuff, which I appreciate. We're going to talk about that in detail, but I want to note, it's interesting that in this environment, the edge could be this iPad I have in front of me, because it's actually the distance from the centralized data. But in the 90s example we were talking about, there was like two solutions. It was like shortening the distance and then caching. And the I guess the inverse to the edge computing access stuff is just local compute. And I know it's weird for people who have computers and phones and stuff right now, and they're more powerful than computers have ever been. And we mostly use them to access data on the internet that's being computed somewhere else. But like, these devices can compute themselves. Talk to me about whether or not, as like a caching equivalent, more local compute is the solution. Because in addition to your company, there are other companies in Canada that are working on stuff like this by building, I guess, like new chips to handle more of this load. I'll name one here, Applied Brain Research. I think they're a Waterloo company. They just got some pre-seed funding, and they're trying to build, I guess, the on-device automatic speech recognition, text-to-speech, TTS, like some of the things that we're talking about with the voice component, making that in a very Apple fashion, system on a chip localized to the device, a dedicated chip rather than a dedicated pipe to make this happen. Talk maybe about how your company is approaching it, and then talk me through the trade-offs, or if these are just like two different solutions to two different problems in this really, really big problem set.
Yeah. So to me, there are different levels of complementary solutions that are tied to the use case for which the user is using it, right? And so when I think about it is, if I am to save certain files to my local device on my laptop, those are different than all the files that live on the internet, right?
Yes.
So there's specific data tied to me, you'd hope so, tied to me personally that live on my computer. I think the same way from a model perspective. So there are certain models that all the context they need is my private data because they're just interacting for my purpose, in which case they should live on my local device and likely will, depending on the model size. For other models that need to pull in other pieces of data or interact across various agents, it won't make sense for them to live on my device because that request will still have to go out to the cloud.
Gotcha.
In which case living on the device doesn't solve anything and just makes my device use up more space.
Okay. So like the voice recognition or understanding what language I'm saying, probably good if similar to graphics chips or other chips, we have a dedicated chip for that on device. but the stuff that allows our kids to eventually like talk to Mickey Mouse or have an Ender's Game style tablet where anything can happen needs more than the device.
Yeah. And I think the other way to think up in your mind is like, if you can consider Jevons paradox, right?
Yeah.
Like to your point,
We've tried to discuss that on the podcast before. I don't know how well I've done with it.
but so if you go back to the 90s, the iPhone I have today is like a supercomputer back in the day. It's like absolutely outstanding. Yet we didn't stop developing our requirements from a software perspective because the iPhones exist, right? So as we get more and more technology with more and more capabilities, we will consume those resources to create even further productivity around software and so forth, right? And so
we're not finding the efficiency of mass distribution here because it's just driving more and more demand.
Exactly. And so I think from that perspective is as things continually move to the edge, there will be continually larger models with larger workflows that are going to require even larger compute capability cycles.
Okay.
And so that's why I say you have the three areas. You have centralization, you have availability zone edge, and then you have local device edge. All three of those I expect to be continually needed. And it's more about fitting the right item to the right local area to get the right outcome.
Okay. All right. I think at this point, you've earned a little bit of the right to talk specifically about where PolarGrid fits in this and what you're doing in that kind of like air traffic controller middleware. And then just I guess maybe some of the early traction you've seen in your approach, right? Because this is where like we're talking about optimization. We want to see deltas in performance, and you've got some numbers.
Yeah. So for us, what we're really trying to do is sort of solve three key things, right? So we're trying to make it really easy for developers to make their stuff load faster, to put it in the most basic fashion. And so we want to make sure that they're able to take advantage of our infrastructure, see the latency improvements, and that it's under 5 minutes of their effort, and then they can forget about us. The second part for us is around that orchestration piece of how do you make sure that the user request goes to the right server when you're operating a global network? It's a fairly complex piece of software, but that's the key differentiator that we have in our product. And then the third piece is really around making sure that there are servers at the availability zone level so that you're able to get that lowest latency. And when you put the three of them together, that's what gets the user experience where developers are able to say, cut my latency, a few minutes effort, let me walk away. And we really used Heroku as the inspiration for how you go about building such a thing.
Yeah. Heroku and Akamai are like two really good points of comparison here for people engaging in this convo, because you're not saying we're building the thing that's going to help our kids play with Disney characters on their devices. You're like in the 90s website example is like you're building the stuff underneath the GeoCities that's underneath the content experience so that the people producing the infrastructure to produce the content have a real easy time to do it.
Totally. And I think our general ethos is we saw this problem and we said, how can we be helpful within it? And what's really fun for us is when you're building a platform, you aren't fighting against other people. It's how do we build this up on a global basis to make everything go faster? Yeah. And so it's a fun way to be able to work with our customers and drive things forward.
And then again, you're specifically targeting voice as a place where that optimization is really going to be helpful. But the interesting thing, so those global tech company giants that I talked about before, those big hyperscalers, at least two of them in Google and AWS, have a real dedicated interest in voice. They have devices that they've put in as also being consumer tech companies and not base level infra for all of our digital experiences, have end user touch points, and they want people in the home saying, hey, Alexa, hey, Google. I wish I could say Apple wants people to say, hey, Siri. It doesn't seem like they're actually focused on the tech for that. They're not in this equation. What's preventing AWS or Google or even Microsoft, and they don't consider about the consumer part, but they just want to own infra and let agents run wild for content, prioritize voice in a way that you can't?
Yeah, so I think it's the constant question for startups, right? How does David beat Goliath? How do you win these big sort of fights, right? And so I think there's a few parts, right? Having run a large public company, having worked in startups, like inherently startups are always faster. They're always more focused, and they're able to drive that pace of shipping out new product capabilities a lot faster. I think the key part really in this is in terms of, are you taking an existing infrastructure stack and trying to force a new capability into it versus are you building it purpose built from the ground up to solve that end problem? Okay. And so I think that's where our big advantage comes from. And again, we sort of took the CDN playbook as a way to look at this. Of the same question applies to like, why were Cloudflare and Akamai and Fastly able to be successful when the hyperscalers were there? And naturally, they would want that internet traffic to travel over their pipes, right?
Because they were still too busy building the data centers and the other stuff to focus on that optimization?
Yeah, I think it's a mix of they're too busy on it. It wasn't the core value prop to their customers. Like AWS is fantastic and has everything for everyone, which works really well if you're a Fortune 100. Okay. But if you're not a Fortune 100, it is very cumbersome to be able to build out. And it's where we sort of go back to the multi-cloud deployments opportunity in AWS. So AWS has at the region level different data centers across the world. And you have the ability for a multi-cloud setup, but that actually requires an additional entire tech stack on top of AWS, as well as significant expertise to roll out. Yeah. And that's why when AWS Northeast went down, we saw so much of the internet go down with it, because people don't implement that. There is too much friction in the user experience. Yeah. And so I think when you are a large entity trying to implement these solutions, it's always a bolt-on feature, and it doesn't drive the user adoption through having a slick interface that just makes it easy for people to use.
So you're advocating like the company that is passionately cares about that optimization delta is going to win, because that's too thin of a margin for the hyperscalers to care about, but everyone's going to feel that optimization if you stack on top. How big of a market is that? Like we were talking before that we were recording about like Canadian ambition and building and things like this. You're definitely talking about like frontier tech and the next generation of the internet. How big is this optimization band within that, Google, AWS, largest tech companies of all time component?
Yeah. So the way we like to think about it is it's really big, right? and so like the analog of CDNs process over half the internet's traffic. Yeah. So if you believe that Gen AI is the future of computation, you then say, if CDNs were half, what amount is an inference delivery network going to be of the overall total addressable market, right? Okay. And then you take a step back and you say, over the next 5 years, over the next 10 years, how often are users going to expect that when they put an input, that response is snappy as opposed to it is minutes? Gotcha. And I'm bullish that that's going to be a very large number across that. And I think
Jevons paradox means that it's
a big number.
We're going to keep feeling that latency as we look for cooler and cooler stuff to do with our fun AI tools.
Exactly. Okay. Yeah. And I think as you have more competition in a market, as you have users use a product more and more, user expectations just continually to scale and grow. And so products will need to respond to that, and will continue to push the bounds. And when I talk to product managers and product folks, their aspiration is never like, what will get me by? It's how do I create that wow moment for my end user, right? And slowness never creates the wow moment.
Okay. Let's close on that then, because, you somewhere between playing with GeoCities pages in your room and now with PolarGrid, you lived a whole other life in cannabis that we should probably have you back on and just ask you about. But that idea of, we started this conversation with a sense of novelty slowly being replaced by greater demands. And I fully admitted I'm still stuck in the novelty, that I can't see the optimization paths. What are you looking to? What comes next? What's the moment where everyone's like, this is too slow? My AI companion that I made up is not doing the thing that I want. Like, what's the next dot in the line that you're tracking towards?
Yeah. So what we expect is going to come over the next 12 months is you're going to have folks using voice agents, and the users are going to start gravitating to the ones that they can have a fulsome conversation with. I think it's a simple marker, but a very clear marker of, if I have two options and one I have a natural dialogue with, and the other one I'm constantly waiting with pauses for, I'm not going to choose the second. And I think that's going to be the moment that lets people say, I need to make my stuff work quicker. And then you'll start seeing product managers building out other use cases where they use that as their differentiator.
Right. So we're in the middle of the beginning here. That's pretty exciting. And
yeah, our thesis is it's 1997 right now, and it's time to get going on those websites.
That's awesome. Okay. When those websites go live, we might have to have you come back and talk about it. But I really, again, appreciate you coming here all the way from Ottawa just to have a conversation about GeoCities.
Just for you, Douglas, of course.
Thanks, man.
Awesome. Thanks so much.